Okay, this is our last video I'm going to do with reviews. So next week you're going to be spending 4 days practicing, 1 day working on anything you've missed. So you're just going to practice, test, try your best, and I'm going to have live videos open so you can ask questions. So we have this geometric sequence. So first 20 terms. So if you have a geometric sequence and you want to find out what the sum of the first 20 terms, the sum of a finite. So let's put it this way. An infinite would be, the sum would be a, the first term, over 1 minus r. If it's a finite, so 20 terms means it's finite because it doesn't go on forever. Finite, the sum is equal to a 1 minus r to the n all over 1 minus r. Now you got this. We know that n is 20, a is 12, and r is square root 2. Plug it in, work it out, and you get your answer. Next, we have, what are the vertical asymptotes? We should know vertical asymptotes. You set the bottom equal to 0. So let's set the bottom equal to 0, and the best way to factor that one out is I'm going to use the box method. So we're going to put the box here, and we got 6x squared. We got negative 1 here. We want to multiply these two, and we get negative 6x squared. So what two numbers multiply to give me negative 6, but add to give me a negative 1? So that would be negative 3x and 2x. Because when they multiply together, it gives me negative 6. Add, give me negative 1. So, arrows, you got going to the left. So what's common in negative 3 and negative 1? Negative 1. Common between 6 and 2 would be 2x. You got going up, going up. So common between 6x squared and 3x would be 3x. Common between 2x and 1 would be 1. So now we have 3x plus 1 and 2x minus 1. So what you're going to do is figure out, solve this one out, set it equal to 0. So you set both sides equal to 0. 3x plus 1 equals 0, and that's going to be one asymptote. You can go 2x minus 1 equals 0, and that's going to be another asymptote. Whatever makes the denominator 0 is an asymptote, as long as it doesn't cancel off. Remember that. All right, so what's the distance between the points of intersection? All right, so what you're going to do is you're going to go to Desmos and graph this. So I'm going to show you. So you got absolute value of x minus 3 and 1/2 x. So go to Desmos. That's not Desmos. Go to Desmos. So we have absolute value is ABS on Desmos. Put parentheses, you got x minus 3. And then, I'm so sorry. I'm going to clear this out because I'm way zoomed in from the last problem I did. All right, so ABS, you got x minus 3. And then the next graph, you're going to do the 1/2 x. So, x is not in the bottom. Here we go. X on top. There we go. All right, so we have 2 points. Right here and right here. And what you're going to do is use the distance formula. Remember, distance formula is just sort of like the Pythagorean theorem. We want to find out what this length of this line is. So we're going to have a right triangle here. So I'm going to show you both ways. So the distance formula is the square root of x squared 2 minus x1 squared plus y2 minus y1 squared. Or you can just say, okay, we went from 2 to 6, so that is 4 right here. And we went from 1 to 3, which is 2 right here, and then you use Pythagorean theorem and find this. Let's call it C. I don't care how you do it, but they're both pretty much the same thing. All right. Let's look at the next one here. Thinking about this. Okay, so this is another find the sum. And actually, this one's nice enough to actually have given you the formula. So your first number is 8. The number of terms we have is what you got to do is say that we have, well, this is not, actually that is. So this is 250, but that's 2,500, but you forgot to add your first one here, so that's going to be 2,501. That's your N. And your R, what are you multiplying each time? So first, all you got to do is look at the first term to the second term. So we went from 8 to negative 8 over 7. What'd you multiply to 8 by? So what times 8 gives you negative 8 over 7? Well, if you divide by 8, multiply by the reciprocal, negative 1 over 7 is your R. There you go. So plug in your numbers, your initial value, your R, your N, and get your answer. Okay, domain. So you can graph this one, but the easiest thing to do is we know that negative x plus 2, whatever's inside a square root has to be greater than or equal to 0. So I'm going to move the x to the other side. That way we don't have to worry about changing any signs. And so once you do that, you find your answer. That easy. Now, and let me go back to that one. If you wanted to and you want to move the 2, let's see, we have negative x plus 2 is greater than or equal to 0. If you subtract the 2, you have negative x is greater than or equal to negative 2. Then we had to divide by negative 1. And when you divide by negative 1, you have to flip the middle sign, and that's what's going to happen. Same thing. It's just backwards. All right. Next, an investment has a balance of that. Okay, so, and earns 3.2% each year. So when you're doing percent each year, what you're going to do is, let's just say if you're adding interest, it's always going to be 1. I'm so sorry, I didn't question. It's always going to be 1 plus R. Remember the P, 1 plus R to the T? So it's 1 plus R. So it's 1 plus 0.032. 1.032. So that's what we're going to multiply to our last value each time. So which one of these are we doing that to? Think about looking at what's happening here. We're multiplying by that each time to give us the initial amount plus the new interest we got. And then it says that we add $150 each year. So we're adding $150 each year. So you got to think about which one of these are just adding $150 each year. So looking at these, there's only 2 of them. And finally, you have a balance of $2. That's what you're starting off with. That's your initial value. Which one has a balance of $2,000? Only these 2. You start off with, that's your initial value, BO. So, and I think you guys can figure it out because right now, when you find this one that's being multiplied there, you already know your answer. All right, what is the limit of this one? Oh, this one is very simple. I know it looks like all this extra junk here. All you're saying is, I told you yesterday that you have to simplify these if you can. This one's not going to simplify. And most of the ones you have to simplify are the ones that are fraction. you factor it and cancel things off so you can plug a number in. This one, all you got to do is take 3 and plug it in there. So really, you're looking at f of 3 to get your answer. Just do it. That's all you got to do. The only time you have to worry about simplifying is if when you plug that number in, it gives you an error. You're dividing by 0. You're taking the square root of a negative or something. All right. This one, X is the number of pebbles in the tank. Approximately how many pebbles in the tank? This one's not a bad one here. So we want to know that T, the temperature. So we want to know how many pebbles are in the tank as a water temperature. So the temperature is 58.3. So we know that that's what T of X is. And we just have ln 1 plus x plus 52.4. Now you could solve this one if you want, but what you could do is you go first graph, second graph is the right side. So first graph is the left side, second graph is the right side, and find out where the lines intersect. Tells you your answer. If you really wanted to work this out, you could have subtracted the 52.4, and that would have been, let's see, we got 5.9 is equal to ln 1 plus x. Then you take the e to the power on both sides, so e to the 5.9. That cancels off, so we're left with 1 plus x. Then you subtract your 1, and that is also the answer. It just doesn't give you one of those nice answers right there, but you can just plug that into a calculator and get it. Both ways work. Which is a solution set here. Again, I suggest just doing this as the first graph is your left side, second graph is your right side, and find out where they intersect. And remember, when you're plugging in a number into Desmos, do y equals 0, because otherwise it doesn't read it. If you want to do it another way here, there's an awkward way of doing this one, which you have to convert. So you're going to have to say that y is equal to e to the x, then substitute that in, which makes this a quadratic. 5y minus 12. Then you factor that one out, or solve for that one. And then once you do that, then you actually have to go back into it and then replace with e to x and then solve the problem. This one's easier right here. All right, so next, this one's not horrible. What you're going to do is you're going to take -3 and plug it in the one that has -3 in it. So -3 is here or here, but which one's equal? So what you're going to do is plug a -3 into the first one. So you got -3 squared plus 2 times -3. Make sure you square before you distribute the negative. And then you're going to take -1, which falls in between these two numbers. So you're going to go 2, 1/3 times 2 to the -1. And whatever answer you get there, you're going to multiply by 2. And then you're going to take the 4, and 4 falls in the last one. So you're going to go 2, 4 minus 5, all over 4 minus 7. So this is adding between those two and subtracting between those two. That's going to give you an answer. But you just have to plug in each one and find out which domain do these numbers fall into. Because you don't plug them into all of them. You plug them into the one that's in this domain. And these are your domains right here. So next, which function goes to positive infinity most quickly as x increases? This one, you're going to graph each one of these and see which one has the steeper slope. The one that has the steepest slope, that's your answer. All right, next one, which expression is equivalent to that one? This is one we saw in class, and it didn't work out because you can plug this into Desmos right here and plug these into Desmos to see which one matches. I'm going to show you the trick to work with Desmos. The top is a difference of squares. This top is going to factor into sine squared theta. We need more room for this one. So we have sine squared theta, because squared times squared is a fourth. You do plus, minus, you have cosine squared theta, and then the bottom is still going to be sine squared theta minus cosine squared theta. Now, you can plug this into a calculator if you want, but right now we see that this and this are the same thing. So we should know what this is because this is a trig identity. All right, what is the solution to the equation here? My suggestion, first graph, second graph, and see where the lines intersect. Now, it will give you a decimal, but what you're going to have to do is, once it gives you a decimal, see which one of the fractions equal your decimal. That's all it is. Okay. Ooh, I like this one. What is the sum of the sequence? So we started off with 1, and then we went to 1/10. Then we went to 1/100th. I'm going to change this into fractions. So what we're multiplying by each time is 1/10. So R is 1/10. There's that. And then my first number, A, is 1. So what you're going to do is, since this is ... here, that means it goes to infinity. Since it's an infinite sequence, you have A over 1 minus R. You plug in your A, you plug in your R, and you work it out. Now, it's going to give you a fraction there. Just change it to a mixed number. All right, this one. Oh, this one's a fun one. So as you see, it's a sine function or cosine function here. So let's see, we have 10 is my minimum sunspots per year, and my maximum is 120. So the difference between these two, we're going up 110. So if we split that in the middle, we know that my amplitude is going to be 55. So which one has an amplitude of 55? We know my midline, the middle line here, is going to be what we're shifting up or down. My midline is going to be 10 plus the 55, which is 65. That is my up or down. Well, actually, it's just up on this one, so I'm not even going to put it down. So this is just up 65. So you see, we want to add 65 to the whole thing. Now, the only thing that really you have to worry about now is I don't care about what the period is because they all have the same period, so that's not going to help you. What you need to know now is that we're starting off at 1964. That's my initial value, so we have to shift the whole graph 1964 over. So, if we want to shift 1964, which is right here, to the left because we want to get it to 0, that means we're going to add, we want to shift the 1964 over. So what we want to do is, we see that we're all subtracting 1964 here, so we're shifting it. But the thing is, remember, it only is a shift if you have your B X plus or minus your C. So the C here is 1964. It has to be inside parentheses for this to work. So, looking at these, There's only 2 with it inside the parentheses. So now you know the amplitude, you know the vertical shift. Now you just need to know which one of those are. It's easy and matched up now. Okay, recursive formula for the sequence is that. Sequence for U7, which explicit formula can be used to determine the nth term of the sequence. Okay. So what you're going to do is you're going to take the first term, and what you're saying is you're adding 12. And then what you're going to do is you're going to take the second term, which is just the first term, plus, this U2. U3 is just the second term plus 12. Remember, the second term is U1 plus 12 plus 12. The next one is going to be U1 plus 12 plus 12 plus 12. Next one is going to be U1 plus 12 plus 12 plus 12 plus 12. So what you're going to do is you're going to start off with the first term. So the first term is 7. And you're adding 12 a number of times. So the first time, we added 12 once. The second time, we added 12 twice. Third time, we added 12 3 times. So you're going up 1 time each time. So which one of these functions tells me that we're taking the 7, we're adding 12 a certain number of times, where you have a variable with it. All right, which statement is true about the sequence below? All right, so the sequence below, it gets 4.5, it's going to 12, then it's going to 22.5. It's getting bigger and bigger and bigger. So if it's getting bigger and bigger and bigger, it's not going to converge. Converge means it's going to a certain number. So if it keeps going up, where's it going to? So is it divergent because it's going to infinity, or is it going to 30? Think about what's going on here. If it keeps going up and up and doesn't stop, you should know that one. All right, which statement is true about the 5th term of the 2 sequences below? All right, so what you got to do? So the first one, so we're going to go A5, which is equal to 3, 5 squared minus 6. You're going to get some answer there. I'll let you work that one out. And then what we need to do is get this term, the 5th term. So we know we start off with 10. So the next one is going to be 3 times 10 minus 6. So that's going to be 3 times 4, which is 12. So the next one is going to be 3 times whatever you got last time. So it's going to be 12 minus 6. So that's going to be 18. Next one is going to be 3 times 18 minus 6. So that's going to be 36. Next one is going to be 3 times 36 minus 6, which is going to equal 90. So this is the first term, second, third, fourth, fifth. So this is the 5th one. If you find this 5th one, what you need to do is tell me what happens. And I'll just tell you right now, this one is the 5th term of the recursive sequence. So recursive, this one is explicit. Recursive means that you have to take the last term and keep adding more to it. The explicit means you just plug in the number, it gets you straight there. So figure out which one of these, it's pretty simple here. You see that it's difference by 63, 21, whatever it is, and which one's going to be bigger. All right, another one with a series. Now, since they get smaller each time, smaller, Since it gets smaller, that means it's going to converge. So, and really, to tell you the truth, what's happening here is we're multiplying by 1/2, 1/2, 1/2. So if the absolute value of r is less than 1, then it converges. If the absolute value of r is greater than 1, it diverges. I told you if it gets smaller, it converges. If it gets bigger, it diverges. Same thing, same idea here. So we know that since it's 1/2, it's going to converge. But why? And I just told you why. The third term of the geometric series is 96, and the fifth term is 1536. What is the sum of the first 10 terms? Okay. So, let's see. The sum is equal to A, 1 minus r to the n, all over 1 minus r. We know that n is 10 this time, because it says first 10 terms. We don't know what r is yet, but we can figure it out because the third term is 96, and the fifth term is 1536. Now, you got to figure out how much you're multiplying each time here. And we're missing the fourth term here, so you got to think we multiply something to get to the fourth term and something to get to fifth term. So we got to end up, whatever we multiplied here, we got to divide by 2, because we have to figure out how much we multiply each one time. So you got 1536 divided by 96 is equal to, not divided by 2, we got to square root it. So we multiply by x, let's call it r. Multiply by r and r again. So r squared should be what is being multiplied here. So when you take that and divide it out, we get 16. So to find my r, we square root. So we should all know that r is 4 now. So r equals 4. Now we just need to know the first term. So to find the second term, instead of multiplying by 4 from 96, we take 96 and divide it by 4. So 4 goes in there. Let's see, 24 times? I think, yes, looks like it. All right, and then to get the first term, you take the last term, which is 24, and divide it by 4. That's going to give you 6. So now you got your first term, your number terms, and your r. You plug it into that formula and figure out the answer. All right, so the next thing here, well, that's it. We're done for today. That's my last video, and for review, I'm going to have you practice next week. So.